This video is all about the Linux shell. This is not a bash video where I'm showing a bunch of bash commands. I have different videos out there where I discuss bash in smaller areas, such as process management from the command line, or navigation at the command line, or some of those other videos. This is more customizing it to the point of replacing bash. So this is extreme customization of your Linux shell. This is how to totally rewrite it if you choose to. There's a whole bunch of shells available, though. You don't have to write your own shell. There's plenty of other options. There are some programs that can list those for you. It's also very easy to change which shell that you're using. We're going to discuss some of that too. There's some command line programs. There's some graphical user interface programs. There's also a file which we're going to show. That's how I'm going to do it. You have to edit it from root, but I'll explain that file on here. It's also easy to create a shell of your own invention and even start using your own shell. And that's a demonstration that we're going to do on here. As you can tell, this is not too long of a video. We're going to do all of this in here because it's not that complex. Why would you want to create your own shell? Maybe the cool factor of it, maybe to make it more you, maybe you want to create a easier to use shell for someone else, maybe you want to make a more restrictive shell for someone else as well, or even for yourself. Maybe you want to have the stuff that you commonly use. Maybe you realize that all you ever do at the command line is type one program, one command, so maybe you'll have it to where you can run that program more easily. But we'll get into discussing some of those ins and outs on here. First of all, I do want to talk a little bit about user account information that Linux likes to store. You're going to have a user ID that's a static reference to your user account. It should not be changed. It's attached to every file and resource that you have permissions on that you've created. Every time it needs to reference you, it's going to use that numeric ID. That should not be changed. The username, that can be changed. That's the username that you log in by. Full name is how it refers to you when it grabs your full name out. Your password can be changed easily and should be changed regularly. Primary group ID, that's whenever you create anything, that's the group that it's going to be by default set as until you change it to something else. That's the ID, because the groups work by that ID system as well. So it has an ID and it has a name of the group. And that's the way, that is your primary group ID. It stores that ID anytime it needs to reference that group. And then any other additional groups that you are a member of have permissions on. The additional groups are also stored by Linux. Two other ones that are a bit more important. The last one, very important. But the home directory is where you get into. When you log in from the command line, that's the directory that you're working in. That's your initial working directory, is your home directory. The shell is your initial working program. That's the initial program it's going to start for you and put you in. You'll notice as well, I have the S and the H on that shell capitalized. That is not a typo. I do that to remind us that shell programs are oftentimes, like the actual shell itself, like bash for example, they oftentimes end in SH. So bash is the Bourne Again shell. B for Bourne, A for Again, SH is for shell. That's generally how shell is abbreviated. It is not required. Our example program that we created, actually all of our examples that we have for the shell they're not going to end in SH. And the one that I wrote, I did that on purpose to prove that you don't have to do that. But it is a good convention. If you are going to write a shell that you're actually intending to use, you might consider ending it with SH. So, properties of a shell. Okay, the shell is the program that's started initially when you log in, and from there you're intended to be able to launch whatever other programs that you need to launch, and then that's the point behind a shell. The shell must be executable. We're going to be using a PHP script to do our shell, but it's going to be using a hash bang for the interpreter and marked as executable. Therefore, it's a program. That's all you really need to comply with that executable requirement. It also must be a command line interface or console user interface application. If you try and make it as a graphical user interface application, you're going to have some problems, because graphical user interface applications, they are expected to, they have libraries that are meant to connect with the GUI server that should be running with your other GUI stuff that's actually supposed to be started. From a shell like this, you're not expected to have access to a GUI. So that could be a problem. Stick with CLI or CUI applications for this. And you should have access to any of the other programs that you would want to have access to, system functions that you should have access to, system restart, changing your password, whatever programs you need to get into. You want to be able to make sure that you have access to that from your shell, because your shell is what you are going to have once you get it to where that's what you log in on. It's got to be able to do all of that. And then you got to be able to log out. To log out from the shell, what are you going to do? You don't need to import any libraries or anything extra to make your shell function. Logging out is done once you have started another program, and once that program ends, it comes back to your shell. And then you can start another program, or you could even exit your shell. And that's what that is. You're going to exit out just like you would any other CLI or CUI application. When you exit from your shell program, it will log you out of your session that you're logged in as. So, yeah, that's a shell for you. Now let's take a look at one of those programs over here. Actually, this is not a program. This is the data file that manages your user accounts in Linux. Usually right off the root there's an etc directory, and inside that directory is a passwd file. And this needs to be root permissions to edit this. You might be able to read it without being root, I'm not sure, but definitely can't write to it without being root. And that's a good thing. You really want to know what you're doing when you get into this program, because if you make an error on here, you might do any number of things, including make your system just unusable until you are able to fix this file. And if your system is unusable, then you're going to have to fix this file by plugging in your hard drive to another system and logging in as root to that and coming in and fixing the file. So you could really mess up your system playing in here. So if you don't know what you're doing, use another editing application, and that will also show you the list of different available shells as well. In my case, I just have to count on knowing them. So that's my username, and X is for passwords in another file. In many configurations, they do put the passwords not in this file, but in the other file. And the password is not really stored as a password. It's stored as a hash. When you create your password, it stores the hash. It compares the two passwords that you entered, the password and your password confirm, It likes those, or it may even be checking those as hashes. Not sure exactly how that program works underneath the hood, but I do know that when it stores it on your system, it goes in as a hash. And when you try and log in again, it creates a hash of that and checks against what's in your system. So checks that against the hash that's in your system. So your password is never actually stored anywhere. It's always used as a one-way hash. So you should not be able to figure out someone's password by any file in the computer. Alright, user ID, group ID, this is your full name and any other information that it decides to attach to your user-friendly information. This is your home directory inside those two colons. And then over here is, kind of important, our shell. This is our shell program. This is the program it's going to start when it first comes on in. This is where it's going to go. This is where it's going to start. So that is what I'm going to be editing because it's the easiest way to get this video done quickly. You'll see I have my IP on here, something in my own home bin directory. My IP is a program that I wrote to be able to retrieve my loopback IP and throw that into another command for one of my other bash videos that I did. Now we're going to use that as a shell and you'll see this works a lot like the no login ones. It's a program that simply writes a line of text, and we can see that line of text, and then it got to the end of its program, so it logged me out of my session. And that's what this no login will do. It will tell you a quick message that says this account's disabled, it's not available, whatever it be, and exits, so that way you don't really have a shell. So that keeps people from logging in as certain accounts that you don't really want people logging in as. But that's the way that can work. But I'm also going to show how we can use any other CLI application. These programs I'm using were not modified from their original intention. They were not intended as shells. So just any of these programs can work. I'm going to launch Midnight Commander as my shell. Midnight Commander was never really meant to be used as a shell, but it would make a kind of a cool shell. But ideally, if you're going to run Midnight Commander, you would want to start it up after Bash has been started up. Set it as a startup program for Bash to start. But here, yeah, we have a way that we can, this is a console user interface program, so we can read the mouse. It's got this whole, really fancy console type thing. And we're using this as a shell, which means, want to use your plain shell? Press Control-O. Well, what happens whenever I do that? This is my plain shell. I don't have another shell. It didn't start Bash. It's expecting to go back into Bash or Sash or any of the other shells that I might be possibly running. But it's not on here. Because the shell is attached to the user account, just like the home directory is attached to the user account, everyone can run their own shell. And that's kind of what we did here. But here we didn't run a shell at all. We ran Midnight Commander instead. So if I exit out of Midnight Commander, I'm logged out. So that's, yeah, that's the way that would work. Now let's take a look at one more option that I have, and that is to run my own shell. And first of all, I will go ahead and talk a little bit about what I programmed here. So here's our hashbang. This is an executable file. It's in my home directory, similar to, it's in my home directory over here, home bin directory. Right in with all my other commands that I've been writing and showing it to you guys on other videos. And yes, this is a parody of Microsoft DOS. This is the husband for it, but as you can see, the husband doesn't do as much as the wife in this video. So this is just an example to show that yes, you can do it. It's very easy to do. So this is Mr. DOS, the husband to Ms. DOS, from the Megasoft Corporation in our case, right? And yeah, it's one up from, I had to one up Microsoft. Instead of 622, I did 623. All right. Got my prompt, and yeah, this one here, I probably really should have taken in I probably should have used the path variables to put that in there, but I'm not going to change my path on here. And it was just for an example. But here I've got a DOS-style prompt for my home directory, as if it's on C drive. Linux does not recognize C drive or any of that. All right. It's going to give me that prompt, and then it's going to take in a line. And this is an infinite loop, while true. So to exit from there, I have to use a break command to exit that loop. But that's what this whole thing is it's a loop where I take in a command after my prompt, and I'm going to expand whatever I entered, where I'm going to have my first element is going to be one thing, and my everything else, I only have a limit of 2, so everything else gets crammed into the second element of my array. And that's what I'm doing here, is I took in a command line, and I'm breaking that into a command array, which makes it a little bit easier for me to work with here. New command. So now I'm going to check this, and this is to upper against uppercase. So this is now case insensitive, is what I just did. I made my commands case insensitive. The Linux command is going to run against a backtick operator right here. That's going to send it to the system. That's going to say system run whatever my argument is. That way I can run every other command in my whole system. I have access to as much as Bash has on this by that one command. I also have a help command that I can use for my shell that will give me my list of commands. Now, ideally, I should be able to get a better description of what they do, but hey, it's just for my reminder. But yeah, we've got a help command, and that is good to have a help command in your stuff. You want to be able to remind yourself what your commands were. Type. That's similar to DOS's type in this case, similar to Linux's cat, in the sense that we are going to dump out file contents of whatever file using type. So type space file name, we're going to dump out whatever's in that file name. dir, that's very similar to Linux's or to DOS's directory, and it's similar to Linux's ls command. And you know, I didn't really do any changing of directories in here because this is not too heavy on here. But yeah, so whenever you type in exit, it asks you if you're really sure, and then it breaks on out. It doesn't really ask you for confirmation. It's just going to dump those out for a joke, and then exit. And then over here, if we don't recognize any of the commands, we have our error on here. Instead of bad command or file name, we have it's a rotten command or file is missing, and whatever we entered for the command. So these are all this is how I wrote my shell. So I wrote a shell with about 46 lines counting my directives to enter script and counting my hash bang. That's our shell, and that is now what I'm going to be logging into on here. So let's see what that shell looks like. So we are in Megasoft Mr. DOS 623, and I can enter whatever command I want to from Linux on there. You know, I can get my help. I can also, and see, I'm also entering it as lowercase. Remember, we did it as case insensitive. Hey, I could use whatever. Okay, it's case insensitive. Let's get the source code to that MyIP program up here, right? Pretty easy on that. So yeah, we've got type in there. What's our directory like? You know, we did the ls. Boom. And then we can also exit, or we can type in a rotten egg command, right? And it does not recognize that. But when we exit, you know, am I really sure? But now I'm back in Bash. I've logged out of that session. I'm now back in my own session now. So that's how easy it is to create your own shell. Doesn't take a whole lot of work to do that. Have fun. Thank you for watching.